Started. Can everybody hear me? Yeah? I'm all mic'd up? Okay. Hey, thanks guys. I know it's 4 o'clock and it's been a long day, and that last presentation was awesome, so we're following up a good one there. So we have an hour. We have a lot of slides. So we're going to try to get through this quickly. There could be sections that we possibly can't get to, so we'll do the best we can as fast as we can do it. Arbitrary title, right? Android development for designers, whatever that might sound like. When we agreed to doing this, it sounded like an easy task, but then once you started creating the PowerPoint, you realized it's not so easy to do that, right? Because learning how to develop an Android comes from a lot of different ways, and we wanted to create this so that it had a linear fashion. And so we're going to tackle that the best way we can, and hopefully it makes sense for you guys. So my name is Ed Murphy. I have my Twitter handle here. I never use it, so I'm going to start using it maybe after this. And I'm a master software engineer for Capital One.
Hi, good afternoon, everyone. My name is Vineet. I'm a developer at Capital One.
Yeah, let's get started. So basically going to cover these contents today. You can't really learn about development without learning Android Studio, so we're going to cover that quickly first. Then we're going to just get right into it, right? So we're going to cover what activities and fragments are. I'm sure you've heard of this. Layouts, widgets, messages, and then, of course, resources, which is highly important to designers. And then we have a walkthrough as well, so creating your first project. If we can't get to the walkthrough today, you can always get this PowerPoint and step through it on your own time, and essentially just create a project from scratch, and away you go. Android Studio currently is in 2.1.3 is the stable version. They just released Nougat, so we're in API version 24. Platform version 7. Your Nexus devices are getting updates now, so within the next few weeks, most of those will have 7.0 ready to be installed. And then into Android Studio, it has the current support library is 23.4.0. The support library is important because it includes support for some of the views and layouts that you find throughout a lot of apps, including the recycler view, card views, which are reused all over, grid layout, and a ton of other fun features. The Android Studio also provides a canary version, so 2.2. If you were in the Constraint Layout portion earlier today, he demoed that using Android Studio 2.2, so just worth noting. Helpful links, right? So we're not going to go through installation today because that would just take too long. So you'd want to take a look at that link if you're going to get set up. And then obviously an introduction to Studio. And it includes a lot of things like best practices, quick guides, all the things that you'd want to know to become a good dev using Android Studio IDE. Right, so once you have it installed, the first screen you're going to probably encounter is this, which is going to include the project tool panel. So this is where all your files and resources are found as part of a project structure. You're also going to encounter the XML panel, so the editor. This is the actual source code. Here's a layout file, so we're looking at it in .xml. The third panel here is the preview panel. So she had mentioned earlier that the native flow for creating prototyping would be done in this. So it's very helpful to look at what you're doing while you have the editor open. And then at the bottom, we're going to cover the design layout versus the text. So currently we have text open, which is why you see the XML layout. Today we're going to focus mostly on the designer mode, not the edit mode, but it's important to look at the code too because we're trying to teach you how to dev. So, yeah.
From a designer perspective, this is the designer mode, which would be easier for visual purposes. We have 4 panels here. The first one is the palette panel. It's a list of Android-provided widgets and views, which can be simply dragged and dropped onto the layout, and which is the second panel view, which is the view of an emulator review of a selected layout. And the third panel is a component tree. This is where you can see the hierarchy or the structured views, which is nested within a layout. And the fourth panel is the properties panel. This is where you can define and modify or edit any attributes according to your views.
Right. What's helpful about that too is as you're learning, you're gonna start to play with all the different views that are available, and looking at it in a visual way in that panel specifically is that you will start to remember the properties that associate with that view, and there are a lot. So. Right, so just a detail on the design editor view panel. At the top, I highlighted two of these. There are a lot of widgets here, but these two specifically, you can change the skin that's associated with your preview layout. In this case, I have the 5X skin. And then you can quickly change the orientation with the number 2 here, that icon.
And here we're just showcasing different views. On the left here is the Android Wear, and on the right is the Nexus 5 skin. This is helpful when we are developing applications for other Android devices. So this would be an example of how your application might look like.
Right, real helpful to be able to see it visually. So we're going to jump right in. That was the Studio IDE for the most part. We'll get back into it through the walkthrough and other various parts of this presentation. You can't really talk about Android development without tackling activities and fragments. There are ways around using multiple activities and fragments, but for the most part, and at Capital One in the 5X app, we use the activity and fragment model. So the idea is simple. Activities are your pages in Android, and fragments are like reusable sections of part of that page. So the concept goes, if I had enough real estate to show activity A and inflate fragment A, I could instantiate and maybe click on an element in fragment A and create activity B and show fragment B. But if I had enough real estate to possibly show 2 fragments on one screen, Android can support that natively for you. So if you had like a tablet or you just changed to landscape mode, activity A in this case can actually orchestrate the call between fragment A and fragment B. So, and that's all built in natively into the Android ecoscape. And so this is like a little bit easier to understand the concept here. So basically between contacts and contact details, some of you might recognize your name up here. And so the idea is that like if you didn't have enough real estate and you clicked on Katie Thompson, for instance, you'd be taken to another screen that had the contact details on her. However, if you could inflate 2 fragments because the space allowed it, you could do that in one screen, which is helpful. And it's done in a responsive manner, so there's not a lot of additional code we need to write on the Android side to provide this kind of functionality, which is cool. Right, and so that takes you into the Android manifest. The manifest itself is where you define all your activities, so all the pages that make up your app. The idea here is that you have to define an activity here if you're going to launch one, right? And so your app will crash unless you actually define it. What's interesting too about the manifest, if you're creating a project through the wizard, you get the app bar for free, and I'll show you on the next slide what I mean. When you define the activity, you're defining the hierarchy of your app as well. So in this case, I have a parent activity, and I also have a child activity, and I've defined the child activity's parent as the parent activity, and that creates a level hierarchy for your app. And what I mean by that is, if you were to have a launcher activity, and you've defined your hierarchy in the manifest, if you're using the toolbar, by default, since you created that hierarchy, you get the up button for free. It just shows up, which is kind of cool. And the idea is that you can have multiple childs that associate with one parent. So no matter how you get to one of these children as you navigate through, it'll always take you back to the level that you associated in the manifest. So, and you can't talk about ABB without talking about DBB, which is device back button. So device back button is very similar to navigating through with the up button, but it takes the history stack into account. So it's the idea, again, that you've come in through this launcher activity, and you're navigating through the history, but you always navigate back to whatever was in the history stack, not what was in the level. So it always adheres to whatever you were doing in terms of the flow. including you can attach a no history property to an activity. So I can get there, I can look at it, I can go back to the previous one, but if I navigate away from that and I attempt to go back, since it has no history, you always go back to whatever's in the history stack. It simply doesn't get added to it, which is helpful because that is like a place where maybe it's informational, it's not necessary for the flow, they need to see it one time and never see it again. So.
Well, that was the backhand part of the development, and I'm going to talk about layouts a little bit, which are a crucial part of application development. Layout is where we can display our views and all the great work designers do. This is where we can actually present them. Android provides us quite a few layouts. The most common are the frame layouts, linear layouts, and relative layouts. They actually act as they are a parent view for other nested views. Layouts contains all the child views, not only child views, but they also contain, you can also put other nested layouts inside a layout. They give a quick way to organize and display our views and widgets. And the most common, most of the layouts have these common attributes which needs to be defined, IDs, width, height, padding, and margin, and so on. And the views are, you can see here in the XML example, where you can see all the views can be nested within the layout. And the nested structure of the XML is how the hierarchy is established in the layout.
Right. So the order in is important. So in this case, the first view in is the last to show. So in terms of Z index, the last view in this hierarchy will be the first to show. Right. So common attributes. Layout width, layout height, you have to define those for all layouts and views. Other ones are padding top, bottom, right, left, and then just padding in general. If you're familiar with CSS and HTML, some of this is going to start to look familiar. So margin top, margin bottom, right, left, and then all margins. Layout gravity is where you get into some interesting stuff. Basically what you're denoting there is that you're saying, hey, parent container, my children need to be aligned left, essentially. Same with background. That can be applied to almost anything. In this case, I'd be filling a background of blue. So the frame layout, just kind of taking a deeper dive into each of these. This is kind of like your setup layout. It doesn't do a lot in comparison to linear and relative, but it is helpful because it's more optimized. It's lighter weight, so to speak. In this example, I've got two nested views, and they're both defined at 100 width and 150 height. I'll get into what DP means in a moment. The gravity is set to left top for the first view and right top for the second. And then we also have a dashed border around all of it, which is defined on the layout itself, or the parent container. And then there are background colors also defined here. And that's generally what you would get if you were to compile that XML and let Android do its thing on it. So. Linear layout, like I mentioned, does a little bit more. Yeah.
I'll explain a little bit on linear layouts. Linear layouts display multiple views and widgets in a single direction. So in order to set layout direction, you have to use an attribute orientation. You have to set an orientation. It can be either vertical or horizontal. And all children of linear layouts are stacked one after the other. For example, in a vertical list, it will only have one child per row, and it doesn't matter how wide they are. As linear layout respects the margins between the child and the gravity for the child views. Linear layouts also support the weight attribute, as it assigns a value to its child view. For example, the larger weight value, if a view has it, the larger space it it occupies on the screen. And then the child view can have its own weight value. Thanks.
Right, so an example of that is
Yeah.
here. Did you want to cover this?
Yeah,
Side?
sure.
Sure.
In this example here, I have an example of two linear layouts. One is laid out vertically and the other is horizontally. If you see the first linear layout, I have 3 rows which are stacked vertically, and the next is 3 horizontally. So, and they do not overlap because as the linear layout has the gravity attribute which is centered right now.
Worth noting too, if you're dealing with weights here, you also have to denote the fact that it doesn't know what weight in terms of width or height it's going to be defined to. So you want to make sure you set either the width or the height to 0 dp, and then it knows, hey, I want to make it wide versus tall. And in this case, we're doing it on the width, essentially. Right, relative layout. So this isn't new, but it's not it's newer compared to linear layout. It basically was created because linear layout, the issue with linear layout is that you get a lot of nested layouts to create the look that you're going for, whereas relative layout takes the hierarchy and flattens it. So you have one parent and a lot of views, and the reason for that is because you can associate the view's location based on another view that's found in the layout. So instead of having a lot of nested layouts with child and then more, and then you get just one layout, lots of views. And so in this case, the relative layout's set to match parent, and I'll cover what that means in a moment as well, but it's going to take up the full screen. And then the 3 nested views the first one has a height of 150, and then it will match its width to the parent. It also has align parent top and align parent left, both set to true. And you have to set an ID on it so other views can associate to it. And so in this case, the second view is going to be below the top view, which was defined earlier. And then the last view has no constraints set. So basically, it's just going to sit on top of all the other views and overlap. So that would look similar to this. This has a few more views, but the concept is the same. The blue, red, orange, and purple are all in constraint with each other, while as the green is does have a constraint, but it's also overlapping. So. Which takes us to constraint.
Constraint layouts. I'm going to talk a little bit about constraint layouts. They're available. They're another layout, another type of layouts, available with the new Android Studio 2.2 only. It's a great UI builder from a designer perspective. It allows to play around with views, and it gives us a lot of feedback immediately.
Mm-hmm.
They're here to create, help us create consistent, efficient layouts, and with a lot of interactive building tools. They're designed to provide a visual way of laying out relative layouts, basically, and as altering the XML with constraint layout is not necessary because everything is done automatically for you when you drag and drop your views or widgets. And much like relative layout, the goal of the constraint layout is to reduce nesting layouts, nesting other views, which may be a performance issue with other layouts. However, the additional features also offers with the constraint layouts is the real-time visual editor, and I'll show you that an example in a bit, and the ability to constrain overlapping views, which is aligning views on top of another view.
Right, but still holding on to the constraint, which is new to constraint layout. Yep.
I wanted to do a demo, but provided how much time we have. But here's an example how you would create a constraint layout using Android Studio. It's pretty much like creating any other layout. You pretty much right-click on the resource folder, under resource folder on the layout folder. That's where all your layouts are set. Ed will go talk about further about the resource. But once you right-click it, and you will see a new resource file widget. You simply name your layout file, and make sure to select your root element as constraint layout. And once you do that, the first screen you will see is this, which at this moment is an empty screen, but with the new Android 2.2 Studio, you see an additional emulator review, which is a blueprint mode. Here you see on the first one is the constraint layout, which is the designer mode, which is the traditional designer mode what we had. Now we have this additional blueprint view where you can actually, any views which are dragged and dropped, and you see an immediate feedback. And here's an example of another additional building tools Android Studio 2.2 has added for us. There's 4 options. The first one, the eye, which looks like an eye, which shows us all the constraints you would add to a view. And the second one, which is auto connect, which helps us automatically add constraints to a view. You simply would, having that enabled, you simply drag a view or a widget, the constraints are added for you for that view. And the third one, which clears all the constraints which you previously added. And the fourth button would be, this behaves similar to auto connect button, but however, if you have multiple views in your layout, and that inference button will automatically add constraints to all of the views on the layout. And here's an example of if I drag and drop a widget, you would see a view on the blueprint would look like this, with the helping tools, which are called handles in this case. The handles help us, the first handle, which is a resize handle, which help us resize the button or an image according to our size. You just simply drag it. And the second one is a constraint handle, which is an anchor point where you utilize this to add constraints to your views from one anchor point to another. Should we show a quick example?
If, nah.
In this example, I'm simply adding an image view, going through a wizard again, and just dragging and selecting a default image from the editor, and which looks like this. And here I had the auto connect enabled, therefore the editor automatically added all the calculated constraints for me. So if you see the lines, the image view had constraints to its parent view. In this case, it's the layout. So I have at this moment, I have a constraint on the top of the view to the parent view of the image, and the left of the image, and the right of the image.
Just use the clicker. It's all good.
In this example, I have added additional views, and additional constraints were added for me automatically. So the image view is defined as a constraint view for both button views. As you can see, the arrows that are created between the views that indicate the constraints. In this case, also the bottom button has a constraint to the bottom of the top image view, and it also has a constraint to the left of the image view for the bottom button. Whereas the top, I have a constraint from the top to the top of the image view, and right of the button view to the right of the image view. This actually, the constraint layout allows us to do this efficiently without editing any codes. Whereas previously we had to, this was not possible in a relative layout unless adding negative margins. And this is just an example of a constraint layout XML would look like. And here the image view is the parent view, and it has constraints to the both buttons. And the image view has constraints to the right off to the parent view, and the left off and the top off, as earlier mentioned. And the button has the constraints to the bottom. The button has the top constraint to the image, to the bottom of the image. And the button has a constraint on the left, to the left of the image for the first button. And the button for the second button has the constraints to the top of the image view and the right of the image view of the button. So therefore they align and they overlap in this example.
So you should note too, so when you're using the handles, this is going to get created for you in part of the XML. He's just simply showing you the XML because this is, development track for designers. So this all gets auto-generated, including the IDs that get populated. So there's not much you need to do when you're using the blueprint editor. So just want to call that out.
So yeah, so this is just an example. And if you want to explore more with constraint layouts and play around, there's some helpful links you can explore further.
Sure, great, thanks. Right, so let's just dive in real quick. So widgets is what we call views in Android. Don't know why, because they themselves name things view. So text view, image view, button view, switch view. We got a lot. We're going to get through some of these quickly. Text view is one of those ones you're going to see all over the place. What makes it unique is obviously the text attribute here, where you define the text that's going to be shown. It's got other ones that are specific to it, like text size, color, all caps. So the word new text would be in all caps. Text style as well, so bold, normal, italic, that kind of thing. Again, very similar to CSS and HTML. What's interesting about this one, though, is you can set layout gravity center, meaning it needs to be placed in the center of its parent, but it also has a gravity attribute, meaning that within the bounding box of the text view itself, I want that text to be center aligned, which is kind of cool. And again, margin top, things like that, some of the common attributes. Here's an example: large text, medium text, small text. Awesome. Image view, same thing. It's got some standard things that you normally do with height have to be defined, but in this case you can set a source, which is on a drawable resource. I'll cover that in a moment. What makes image view unique is the scale type: center, center crop, inside, fit XY. That looks like this. So center is what happens when you set center for the scale type, and it just literally will set the image centered, and it will not adjust the ratio, so it will not scale. Center inside will center the image as well, and it will scale to fit the shortest side, so in this case the width. Center crop, same thing, but it's the opposite. It will stretch to fit the longest side, so the height in this case, and then fit XY will just make it look terrible, so don't use fit XY. Button views, same thing here. So you set the text on the button view, which is the label for that button. Switch has a checked attribute of false or true. It's a Boolean, same with toggle. And then image button is a fun one. Both switch, toggle, and image, or all three extend the button view class. And you can set a drawable source for the image button. It's a clickable image. Few examples of those. We threw a radio button in there, and I guess a checkbox for good measure. The toggle button is on by default in this case. Menus and messages, so kind of have to cover this because it's Android and this stuff's used all over. So the drawer menu, which is normally used for navigation, we use one. It looks like that. Slides in from the left or the right. You've got to define it in this way. So the drawer layout itself is a type of layout. It's the parent to both the main content and to the drawer layout content. You can only define two child elements within this, or you will get a crash. You must set layout gravity to left or right on the second one, or you will get a crash. And you can use the include tags here, which we're not going to cover, but I'm going to cover quickly. Basically, the same thing as HTML. You can include content from another XML file in this fashion, meaning you can reuse it in other XML layouts. So this is a good example of doing that. Again, looks like that. Drawer layout also supports peeking, so if you touch the side, it'll slide out a little bit, letting you know that it's there, and then you can slide it the rest of the way. You can also open it with a button click or pretty much anything, actually. The toast message, so this is done in Java code, can't do it with XML, and it looks like this. So basically, you get a small message that pops up at the bottom. You cannot interact with this message, and it will go away after a certain delay. or duration that is. Interestingly enough, if you were to hit the back button while it was showing, in the case of screen B, it still shows. So it's not tied to your app, it's tied to like the system. So just keep that in mind. You can set a long or a short delay on it, and then it will go away accordingly. Snack bar, same thing. So the idea is that you're going to create a snack bar. It's going to show up at the bottom of the screen in this case, animate in. There are two forms. You can create one with just text, or you can create one with an action button. Again, it will just dismiss on its own. If you set a short, a long, or an indefinite, so it could stay forever until you dismiss it with code. Again, got to do it with Java code, cannot be done with XML. And this example shows both. One without an action, and then the second one with an action. And you have to override the onClick too, so you can actually execute something when someone clicks on that action. Right, so that takes us to resources. So this is really, we debated whether or not we wanted to cover this first or last. This is like the space that most designers would play in. But I wanted to cover everything first, so it made a little bit more sense on how we apply these things. Resources are just that, they're resources. It's a way to reuse content, and it will cache some of that data for you as well, including the drawables, which is helpful. An example of using a color resource looks like this. So it's the idea that it's going to give it a name, like a string value for a color, which you can reuse all over the place. It's in hexadecimal value, but it also supports the alpha channel. So the first two values that I've highlighted in red here denotes transparency. So you have a fully transparent color, which is why I called it transparent color. Just below that is how you would apply it. So for instance, a background color. That attribute can take a color. And in this case, you can get to color primary through the @ symbol, which is really helpful. Dimensions, same thing. You're giving a name to a value. In this case, padding, margin, button padding. So 16, 10, SP for 12 text size. So just quickly, I'll cover what that means now. So pixels are pixels in Android. You can certainly do 16px, but the problem is you're not supporting higher density devices. So we use device independent pixels, which is what DP is. That is in ratio to 160 DPI screen. So for every 1 DP, it's 1 pixel on a 160 DPI screen. This is the preferred method because you don't know what device the user is going to have, so it stays in ratio no matter what, which is helpful. Interestingly enough, you can set DP as DIP, which is kind of old school, but I guess best practice now is just to denote it as DP. SP is exactly the same thing, but you always want to set it on text values, so like text size. And the reason for that is while it will also stay in ratio based on density, it will also take into effect or into account the user's preferences on font size. So in Android, you can set font to small, normal, large, extra large, huge, I think is the last one. And if you set it to SP, it will stay in ratio to that as well, which is important for the end user. Again, padding, for instance, @dimen/padding. Right, so strings. So you can give a string name. So if you had a lot of content and you wanted to get to that content, but you didn't want to copy and paste that all over your app, you can simply set it in a resource and get to it via that ID. You can also do things like paths. So in this case, Proxima Nova is a path to fonts / Proxima Nova Lite to DF. And again, text, for instance, you do @string / app name. And that would compile to development for designers. Drawables. So again, it's a path. So you're going to drop your drawable into the resources bucket. It's going to be a part of your application, and you're going to reference it through the resources. So whenever you need icon A, which could or not be a PNG file, you're going to get that by referencing drawable / icon A. What's interesting about using the drawables is that it will cache as well. So if you use it in other places, it'll pull it from memory as opposed to grabbing it from the resources directory again. This all culminates into styles, as you can imagine. So it's helpful to use some of these @string, @dimen, @color when you're setting styles, right? So in this case, I'm creating a style for a text view. I call it typography. Its parent is the standard widget text view from Android. To get to that, you would set :style = @style typography to set that text view to this style. Here's one where we're taking advantage of cascading. So same concept as CSS. This uses dot notation. So you've set typography like we did on the last screen. Dot bold is going to override the typeface in this case. And then typography.bold.alert is going to do all of those, including changing the color. And you use it like this. So here are 3 text views: typography, bold, and then typography, bold, alert. So. And I think we got a little bit more time. Let's just jump right into the wizard. So wanted to create a project as part of this as well, so that if you guys ever refer back to this, you can create your project as well using this, which is like a gateway into Android development. We're going to create pages, we're going to create some views, we're going to add some styles, we're going to link those pages, and then we're going to test the application. I think I can get through this in the next 10. Once you have Android Studio installed, I have an old version that's 2.1.2, it should be 2.1.3. You're going to start new Studio project. It's going to present you with this screen, and you're going to give your application a name, in this case, Android Walkthrough, and then you're going to have it doing a name, which is what makes your app unique on the marketplace. So we named it summit.android.com, and that's how users will find you in the Play Store. Below that is obviously the path where your application is going to exist in your file system. Here you're going to target Android devices, so I have phone and tablet selected. The Min SDK is set to API 15. As you can imagine, the lower API that you set, the more devices you can target, but with fewer features available. The Capital One 5X app, the mobile servicing app, just dropped support for 15, so now we're at 16 and above. And you can also click on Wear, TV, Android Auto, and Glass to create projects that will compile to those devices within the same app. So it's totally responsive in that case. The next screen is going to present you with creating an activity. So they have a bunch of templates here. Normally just grab the empty activity, but if you want one with maps or full screen activity or one that has a fab or an action button, you can certainly do that. You want to give it a name, it usually just dumps in main activity. I usually just click finish. And here we go. So we're in the IDE again, and it immediately selects main activity. You're in the Java folder here, and the screen to the right is actually the Java code it creates for you. So not going to get into the activity lifecycles, but the onCreate is one of the methods that has to be there for your activity to launch. In this case, it's going to call super on that onCreate, and then it's going to do some fun stuff, set the content view, which is the main activity XML. And it's going to generate this for us, and it does it in a relative layout by default. And it drops in a text view, and it gives you hello world. So didn't have to do anything, just walk through the wizard, and I've got an app working, essentially. It's just kind of cool. At this point, I'm going to create another activity. So we're going to create 2 activities as part of this application. I'm going to right-click the project path. I'm going to go to New. I'm going to go to Activity. I'm going to go to Empty Activity. Same screen's going to pop up. It's going to auto-populate with main 2 activity. You can denote your layout name here too. So very similar construct there. And then the package name. So that's where I want it to live. It's going to create my second activity for me. Same concept, onCreate is created. It's going to inflate that activity underscore main2 for me, which is going to look like this. Well, actually, no, we're going to get in the manifest. But the XML that's generated is exactly the same, but it does not contain a text view, which is kind of nice. Here, I'm back in the manifest, which is important because I need to establish the hierarchy, like we mentioned before with the app bar. What's nice about this, though, is when you use Android Studio Wizards, it's going to add the activity to the manifest for you, so you don't have to do it by hand, which is nice because oftentimes we forget to do that, and then the app crashes, and you see that very familiar error that you didn't add the activity to the manifest, and you're like, okay. Here, I'm also going to set the parent activity to the main activity, so I'm creating that hierarchy, so I want that up button created for me. So back in the preview editor, I'm going to drop a button into my first activity, well, the XML, that is, the layout. And it's going to highlight it for me. And it's also going to show me the properties panel. And in this case, I'm going to change the button name from new button, which is what it is by default, to open activity 2. And like we had mentioned before, the properties panel is definitely good to look at as you're learning development because you're going to get associated with all the attributes that make up a view. The more you know about that, the better developer you become in Android. This is where we get kind of fun. We would probably never do it this way, but if you're going to be in the preview editor and you're going to use Android Studio to its fullest, you can create on-click listeners through wizards. And we're going to walk through that now. So what we want to do is we're going to try to open up that second activity you created. And the idea is that I have a button now, but it doesn't know what to do. There's no action on that. So we're going to do that now. So we're going to right-click the button, and we're going to say Create On-Click Handler. And it's going to create that on-click attribute there. And then it's going to call it Open Activity 2. Which is what, actually, let me start. We added that, so I added Android on-click equals open activity 2. I right-clicked on it and said create event handler. It then will generate that code, open activity 2, for me in the behind-the-scenes code, the Java code itself. That's where code is going to execute when you click on the button itself. That code is going to look like this. So I'm going to create a new intent. Not going to get into what intents do in Android. You know, I urge you to do that as a developer if you're interested. But this is the way to show the next activity. I'm going to pass in the main activity this, which is the context of the current activity that I'm in, and then I'm going to open main2 activity from its class, and then I'm going to call start activity passing in that intent. So the idea is that the intent is going to launch when I click that button. At this point, you're probably going to want to test your app. You've got 2 activities, and you've got connectivity between the 2. You can hit the play button simply, and if you have a device connected, it's going to launch on that device. When you click Open Activity 2, it's going to launch a blank second activity. Not going to run through creating emulators in this because there's not that much time, but here's a great link. So if you're interested in running emulators because you don't have an Android device or you can't find your cable, go ahead and learn how to do that here. Right, and so what we want to do now is we want to pass data between the 2 activities, which is a pretty common practice in Android. That gives us power in which it's less static. So it's the idea that the user did something on screen 1 and it affected a change on screen 2. So the first thing I need to do is drop in a text view in activity 2, and you can see that there. I gave it an ID of text view, and I gave it a text value of hello again world. And if you were to compile the app again and go to that screen, you'd see hello world again. What I'm going to do now is I'm going to pass some content between the first activity and the second activity, and I want to change that default value. So in that intent, again, that we were showing, that we created to open the second activity, I'm going to create a key value pair as an extra and add that to the intent before we pass it as part of start activity. So it takes a key value and a value. The key is the unique identifier to find this value which, and then the hello from main activity is the new content that we want to port into the text view we just created. So we add that as an extra, we call put extra, and we pass in the key value. On the other side, in the Java code for main2 activity, after we set the content view, which is going to inflate the layout, we now have to get the extras from that intent. We know that the key value is my key ID, and we're going to pull the value out and set it as a string here by extras get string that unique key. So it's going to take that bundle out of the intent on the following screen, get the string out of it. We're then going to get the text view that we dropped in by its ID, which I called it text view. Once I have an instance of that view, I can call textView.setText and pass in that value. Change the text to the value passed in from the first activity. Hit play again, run your app, hit open activity 2, and the new message on the second screen says hello from main activity. That pretty much wraps it up. I was going to take it further, but I felt that you guys can take it from here. So. If you're interested in seeing the demo app that we created for you, this one, you can get it here at this link, and the presentation itself. So that's pretty much it. Yeah, thanks. Yes?
What was the hardest thing when you made the transition to a developer?
So the concept of developing, the hardest thing is the principles involved, which interestingly enough, as you become more acquainted with different languages, you start to see the patterns involved. So just kind of understanding what makes programming work. But once you understand some of those, like you can move into other languages. So like I started with HTML, CSS, got heavily involved in JavaScript, and all that was very difficult for me at first. It was all just Greek. And then once I kind of had a good handle on JavaScript, I moved into the Flash, ActionScript 3, which brought me into procedural, object-oriented programming languages, got into Java, and then just all kind of like, steamrolls. I still love design. I always approach everything from a design perspective, but once you get into development, it's just problem solving all day long, which I love to do. So. We don't use Xamarin. Well, we're not supporting Windows right now, so that would be one reason why we don't. Yeah, but it's also a hybrid model, so it ultimately runs in a web view, right? So, oh, it's native. It does push out native. That's right. Yeah, I don't know. I think mostly because we want to hire Android developers, not Xamarin developers. So there's that. There's a lot of reasons why we don't use lots of different things, but that's normally why. We do. We have iOS teams. We have Android teams. Yeah. But we used to have a hybrid app. Yeah, we used PhoneGap for a very long time. The previous version was a PhoneGap app.
Xamarin's fundamentally different from PhoneGap, and it's not a hybrid.
That's right. You're right. That's right. I guess the support there is pretty good too. A lot of the documentation, if you were to Google something, you're looking for information, you might find the Xamarin pages before you get to the Android pages, which is very interesting. Yeah.
So, as I approach designing an app and laying it out,
Use Principle, by the way.
pretty good.
It was awesome.
Well,
I'm gonna get that. Yeah.
I guess maybe I don't have my mind fully wrapped around activities, fragments, layouts,
Mm-hmm.
and just like how those operate together, and how those respond differently, like for different screen sizes and orientations. Like, what's the relationship between
Right.
those things?
That's a great question. We didn't cover orientation and how that works together, but the idea is that in the resources folder where you set your images, you can actually define whether or not you want to show certain graphics or even layouts based on landscape versus portrait. So Android would decide and inflate that layout for you if it knows it's in landscape or portrait mode.
In Android development, application development, there are two files, XML, which is most of the UI work is done. So as a designer, it would be helpful to focus on that so you can design how your app would look like. And Java files are where you can actually implement your logic.
Right.
To actually make your UI work.
Right. Yeah, so Android took the approach that they wanted to be responsive from the start because they knew how fragmented the space was already because there are Android devices in all shapes and sizes, just all over the world. So they had to approach it that way to make it usable across all the different devices. Whereas iOS is just getting into that now, where it's one code base that ports to all the different sizes. So. Yeah.
If you create a layout and you have different places you want to detect like buttons, but the buttons don't need to be visible, say like a game board, and you want to respond to certain, say add chips to a certain area,
Mm-hmm.
how would you implement that via those layouts?
So views can take on 3 different states: gone, invisible, or visible. So in that case, you'd create a hotspot that was invisible. It still takes up the space in the hierarchy, but there's nothing shown. You can do whatever you want with it: set click listeners, adjust its size, height, anything. So that's how I'd probably approach that.
And those click listeners can be added to not only just buttons, but
Mhm.
in other views as well.
Yeah. Cool. We get a drink, guys. Day over.